This video picks up where the basic calibration video leaves off. It assumes you have captured a set of calibration images and that an acceptable score was achieved in VicSnap. As a reminder, VicSnap is a complete image acquisition software for low-speed, high-speed, and ultra-high-speed cameras. Designed specifically for VIC-2D and VIC-3D, this software allows the user to go from calibration and test image acquisition directly to analysis with one click. Built-in tools for image analysis ensure optimized focus, brightness, and pattern quality. In this video, we'll go through some best practices for capturing test images in VicSnap, including what we refer to as a shape image. Then, we'll run a simple tensile test on a plastic dog bone in the MTS Exceed 43 test frame, capture images of the test with VicSnap, and get ready to import them into VIC-3D. Along the way, we'll review some of the advanced options in VicSnap and cover some basic tips and tricks. The first step is to capture a shape image. A shape image is a single image captured with VicSnap and analyzed in VIC-3D. This is a good way to make sure the calibration is correct and everything is set up properly before actually running the test. This can save a lot of time and money, especially if the test is complicated or the material is expensive. To get started, replace the sample in the test frame. Make sure the Speckle Images button is selected in the VicSnap toolbar and take a single image with the spacebar. Next, load this image into VIC-3D by clicking the VIC-3D button in the toolbar. This automatically opens and inputs this single speckled image and your calibration images and parameters into VIC-3D. Please note, there are several ways to import speckle and calibration images into VIC-3D, and we'll cover these in detail in the next video. With VIC-3D open, notice the project panel on the left. This shows the single speckle image with your calibration images. Click on the Calibration tab and double-check that it was populated with the calibration parameters from VicSnap. The next step is to draw an area of interest. This is another topic that will be covered in greater detail in the next video, but for now, pick the rectangle tool here and draw an AOI around the speckle area as we see here. There is no need for precision as we are just checking for calibration accuracy at this point. Next, click the Run Analysis button in the toolbar. There are many options here, but for now, just click Run. The software will analyze the image to determine the projection error. In this case, the projection error is very low, so we are set to run the test. If this number is higher than 0.1, it will be displayed in red. This indicates that something has happened to the calibration and you need to recalibrate. This can happen when the cameras or tripod get disturbed. Next, click Close, minimize VIC-3D, and go back to the VicSnap interface. We are now ready to run the test. Note, as a static image, the shape image can also act as a reference image. The next step is to check that the analog data is being recorded properly by VicSnap through the Data Acquisition System, commonly known as a DIC. Select the Analog Data button. Note, if it is grayed out, there is no DIC connected or recognized. This button brings up a table of values. In this case, we are only connected to the load output of the MTS test frame. There are 4 channels available. To hide the 3 unused channels, double-click on the channel name. Other devices, such as extensometers or strain gauges, anything with analog voltage output can be recorded by VicSnap in these other channels. Right-click and select Edit Channels to edit the names of the channels and the factor and range as needed. Click Apply. In our case, we can check to make sure that the load data is being recorded by manually pushing on the test frame and taking notice of the corresponding change in the values. Now that we know that it's working properly, we can minimize the analog data window. It will continue to run in the background. Next, we need to determine the capture mode. This depends on the kind of test being run and the kind of data we are looking for. To access the capture options, right-click in the empty space at the top. Next, we'll briefly review each option. timed capture mode captures images with an acquisition interval that is set by the user. Image capture will start and stop according to the parameters set in this panel. The streaming capture mode captures images as fast as the camera can stream and gives users the option to save images at predetermined intervals. This can be useful when maximizing frame rates for higher rate acquisition. The analog capture mode captures images when a certain analog voltage is reached. This can be useful when imaging at predetermined load points. TTL capture is a hybrid capture option that allows you to use a TTL pulse to image capture. Note, the pulse needs to be at least 2.5 millivolts and square waves. Every time it switches from low to high, it will trigger. Once it is triggered, it will capture based on one of the other capture options already discussed. Flex capture provides the option to set different image capture intervals for the test and quickly change between intervals. More details on each capture option can be found in the user manual or the Correlated Solutions knowledge base. For this test, we'll use timed capture. Select the drop-down in the left window to adjust the parameters. In this instance, we'll capture at 10 frames a second while we run the test. A good rule of thumb is to start the software capturing before starting the test to make sure there is at least one static reference image that isn't under any strain. Click Start in the Timed Capture panel to begin capturing images. Then start the test with the MTS software. Notice the images being captured here. When the break occurs, you can stop the image capture. Check to make sure the images are in the correct folder by clicking on Open Project Folder. The analog data is in a CSV file in the same folder. Now, after a successful test and acquisition of images, it is time to move into VIC-3D. In the next video, we'll cover importing the calibration and test images into the VIC-3D software and preparing for DIC analysis. We'll cover defining an area of interest, determining optimal step and subset size parameters, and a basic analysis. As with calibration, every setup is different, so unique challenges can emerge. Our US-based support team is ready to answer any questions or help guide you through the process. Just get in touch with us if you're having any problems.